All right, seventh graders, we've been talking about percents of numbers, and today we're going to talk about how much something changes by percent, or the percent of change. Whether the original number goes up or down, you can find how much, or the percentage of the change. Okay? For example, what if you had to answer this question? The annual production of municipal solid waste in the United States has more than doubled since 1960. Find the percent of increase from 1960 to 1990. In 1960, there were 88 million tons of solid municipal waste. And in 1990, there were 205 million tons. So from 88 million tons to 205 million tons. How much of an increase is that? Or what is the percent of that increase? So that's what we're talking about today, is how to find the percent of increase or decrease. Here's how you do it. You find the difference between the two amounts we're talking about. Okay? So you subtract their absolute values, or you subtract the bigger one minus the smaller one. If it was comparing 205 million tons to 88 million tons, then you would subtract those two amounts. Okay? So do that now. Subtract those on your calculator. 205 minus 88. How many million tons is that? Bethany? 117 million tons? Okay. Now, what was the original amount? What was the amount in 1960? Was it the lower one or the higher one? Was it 88 million tons? Or was it 205 million tons? What was the original amount? The starting amount? Melina? What was the original amount in 1960? The amount we started with. 88 million tons. So what you would do to find the percent of increase is take the difference of the two amounts, 117, and divide it by 88. And then times it by 100 to convert it to a percentage. How much of a percent increase is that, Katie?
132.9.
What is it?
132.9.
So change, now say that in a percentage. You have the number, now tell me the answer as a percentage.
The increase from 1960 to 1990 is 132.9%.
Good, 132.9%. Yep. Depends if it asks for the number as a whole number, or if it's to the nearest tenth of a percent. Depends on what they're looking for. Okay? Let's try a few of these. Look at this example. If the number changes from 15 to 20, is that an increase or decrease?
Increase.
That's an increase. So part of your answer is that the amount is an increase in the percent. How much of an increase? How would you find that, Aiden?
You would do 20 minus 15 and take 5, which is the answer to that, divided by 15.
Yep. And why would you change it? Why would you use 15 and not 20?
Because that one is smaller and you're looking for an increase.
It's not the smaller, but it's the first amount. It's the original amount. Okay? So always use the one that was listed first. That's the original amount. Sometimes it's a bigger amount. Sometimes it's a smaller amount. Okay? If it's a decrease, so for example, number 3, if the number changed from 1,500 to 1,416, Caden, what would you do? What would you do to find the percent decrease or increase? First, you'd have to find the, okay, so you would, what operation would you use? Good, subtract the two amounts, find the difference. Make sure that when you're using your calculator, that you push the equal sign to find the difference. Okay? One mistake is to put in 1,500 minus 1,416 divided by 1,500. Okay? But it wouldn't divide the whole thing. What it would do is your calculator would do the division first and then the subtraction.
That's what I meant.
Right? Because the order of operation says you would do the division before subtraction. But what you have to do is do the subtraction first. So you can either put parentheses around this and then divide it by the original amount on your calculator, so that it does the subtraction first, or you can just push the equal sign and then divide it by the original amount. Okay? Does that make sense? And then convert it to a percentage. How would you do that, Andrew?
Multiply it by 100.
Yep, multiply the decimal times 100. So once you do the division, then multiply it by 100. Pretty simple process, right?
Yeah.
Turn to page 331. See if you can answer this question. Number 10. In the United States, in the 20th century, average life expectancy increased from 47 years to 77 years. Find the percent of increase to the nearest percentage. So the average lifespan at the beginning of the 20th century, so the 1900, like in 1900, at the beginning of the 20th century, was 47 years old. The average person was 47 years old. Wow, that's like staggering, isn't it? And at the end of the 20th century, so by the year 2000, the average lifespan was 77 years old. How much of a percent increase is that? Find the answer. Number 10. Find the answer. How much of an increase is it, Jacob?
43%. Okay.
Did you do 30 divided by 47?
Why would I do that?
Because that's the original amount, that's the starting amount.
But don't you have to subtract?
Subtract them, 77 minus 47 is 30,
Yeah.
and then divide by the original amount, and then times it by 100.
Mm-hmm.
You did that?
Yeah.
And you rounded it to the nearest percent?
Uh-huh.
Sophie, what'd you get? Kaden? 64%. Did anyone else get 64%?
I had 63.
And which you would round up to 64%. Okay? Any questions? All right. Your assignment is on page 331.